Hi, I'm Anand Chaudhary, a rising sophomore in Monte Vista High School. Today, I want to go over limits of piecewise function. You're going to find these type of problems, which I'm going to go over today, in a lot of different tests, and there are usually at least one or two of them spread around through the test, just because of how difficult it may be for other students. So why don't we head on into it? So over here, we do have the function f of x, and it has two conditions: x by x minus 2 if x is less than or equal to negative 1, and x by 4 plus 1 if x is greater than negative 1. Now, in this question, I want us to find the limit. As x approaches negative 1 of f of x. But how would we do that, seeing we have two functions? Now we're going to go back into using our right-handed and left-handed limits, because this is what we're going to do. Now, if you guys remember, to find the limit, one of the ways is to make sure that the right-handed limit is equal to the left-handed limit. So that's what we're going to be doing today with the piecewise function. So here we're given, this is going to be the left-handed limit and this is going to be the right-handed limit, because this is from greater than negative 1 and this is from less than. So let's find our left-handed limit first. Limit as x approaches negative 1 from the left-handed side. So what we're going to do is limit as x approaches negative 1 by x minus 2. Now all we're going to do is, because remember, when you're doing limits, what's going to happen is the x value is going to get infinitely close to, but not exactly negative 1. So what's going to happen is you can just plug it in for a good assumption of what it's going to be. So when you're going to plug in negative 1 here, you're going to get negative 1 divided by negative 1 minus 2, and you're going to get a value of negative 1 by negative 3, which is equal to 1 by 3. Now, in order for us to actually have a limit, both of them will have to be equal to. Now, if they are equal, what's going to happen is that value that we're going to get is going to be the limit. If they're not equal, we're not going to have, first of all, a continuous function, and second of all, we're not actually going to have a limit in the first place. Because what's going to happen is if we have something like that, the graph is either going to have a jump discontinuity, a sharp turn, an asymptote. So we're going to have to find out what's going to happen with this function over here. So here we have the limit as x approaches to 1 from the right side. Now here the function is x by 4 plus 1. X by 4 plus 1. So we're going to do the same exact thing that we did here. We're going to plug in, it's not 1, it's negative 1. So we're going to plug in negative 1. Negative 1 by 4 plus 1. Now you can just do it like this, where it's negative 1 by 4 plus 4 by 4. And over here you're going to get a value of negative 3, positive 3 by 4. Now in this case, the right-handed limit does not equal the left-handed limit, as you can see, because the left-handed limit is equal to 1 by 3 and the right-handed limit is equal to 3 by 4. They're not equal. So in that case, the limit doesn't exist. There's either a jump discontinuity. Here is our second problem. It looks a little bit more scary just because there's 3 different conditions, but nothing to be scared of. F of x has 3 conditions. The first one is x squared if x is less than 2. Second one is negative 5 is if x is equal to 2, and 6x by x plus 1 if x is greater than 2. Now remember, all we're looking for is the right-handed limit and the left-handed limit. So we really don't have to focus about this right now, because it's not helping us with either of the two. But this will be helping us later if this is the function. So why don't we head on into it? We're going to have the same process that we had for question number 1. So we're going to find the limit as x approaches to 2 of f of x. And our goal is to have the right-handed limit equal to the left-handed limit. So remember, what we're going to do first is we're going to do limit as x approaches to 2 from the right side of f of x. And if you take a look at it, the one from the right side is this one over here because it's greater than 2. So if we're going to input this, it's going to be limit as x approaches to 2 from the right side of 6x by x plus 1. Now what we're going to do from here is we're going to input the value of 2. So it's going to be 12 up here divided by 3, which is equal to 4. Now what we're expecting from our left-handed limit is to be equal if we want the function to at least have a limit. So limit as x approaches to 2 from the left side of f of x is equal to, now this is the only function we have left, seeing that this is not helping us with either the left or right sided limits. So we're going to plug it into this. Limit as x approaches to 2 from the left side of x squared is equal to, and you're going to plug in the value of 2. You're going to plug in the value of 2. 2 squared, and it's equal to 4. See, in this case, our right-handed limit is equal to our left-handed limit. So therefore we have a limit here, and the limit tends to 4. The limit as x approaches 2 of f of x tends to 4. Now I did state earlier that there is an importance of this. Now the importance of this is to find out whether the function is continuous or not. All we know here is that if I just draw like a mini graph, at x equals 2, it's reaching a value of here. Now in order to find out whether this is continuous or not, see, this could very well be just a removable discontinuity, where the value is actually up here somewhere. So if we want to find out if it's continuous or not, this value at x equals 2 has to be equal to, it will have to be equal to the same value as the limit approaches. Because in that case, the whole, over that specific interval, that is, because we won't know about the whole graph, at that specific interval, the function will be continuous. So as we can see, it's the value at x equals 2 is -5, but the value that our limit tends to is 4, so it's not equal. Therefore, signifying that our limit exists, but the function is not continuous. So I can write that up here. The limit exists, but function is not continuous. So that's all I have for you today, and I hope you guys enjoyed the video of limits of piecewise functions. Hopefully this will help you in your test. So I hope you do well on your test, and bye. Subscribe and like.